Okay, so the second lesson in this unit is called measuring segments. So we're going to be able to compare and find lengths of segments. So the postulate 1.5, so if you just remember it, postulates are things that we accept as truth. Postulate 1.5 is called a ruler postulate, which basically means that every point on a line can be paired with a real number. This makes a 1-to-1 correspondence between the points on the line and the real numbers. The real numbers that corresponds to a point is called the coordinate point. So over here, to find the main idea is to find the distance between A and B is you can subtract these two numbers and find the absolute value of it. So for example, what's the difference if this A was 5 and that was 8? What's the distance between them? The distance is 3, correct? We know that. But the way they're asking us to find it is we could do 5 absolute value of 5 minus 8, which is absolute value of -3, which is 3. Or you could have done 8 minus 5. That is also absolute value of +3 is 3. So it does not matter which order you put it in. So let's try a couple of practice problems. So S is at -4, T is at 8. So let's do this. -4 minus 8. That is going to be the absolute value of -12, which is 12. It is as simple as that. So what is the length of UV? So U is at 10 and V is at 14. So 10 minus 14 is -4. Sorry. The absolute value of -4 is just 4. What is SV? So let's start again. S is at -4 and V is at 14, so -14. Again, remember when you're subtracting a negative, that will become a positive. None of these examples have that, but that's a good thing to keep in mind. So that will give you -18, which is just 18. And that is all to it. So points A, B, and C are collinear. What do you know about that? When points A, B, and C are collinear, so they're in the same line, so there are basic assumptions you can make. So one of them is if you add AB and BC, what would you get? Well, you would get AC, correct? So that segment formally is called the segment addition postulate, which tells you that AC plus BC will give you the whole AC. So let's try some practice problems with that. So use segment addition postulate. So it tells you that EG is 59. It is asking you for EF and FG. Well, what do you know? What do you know about this? We know that EF plus FG equals EG. So we know that 8x minus 14 plus 4x plus 1 equals 59. When I combine my like terms, I'll get 12x minus 13 equals 59. So 12x equals 72. I'm going to add my 13, and then I'm going to divide my 12, and I get x is equal to 6. But it's not asking me for what x equals. It's asking me for what EF and FG equals. So remember, when I found my x, I need to plug it back in. So to find EF, I need to plug in 8 times 6 minus 14, which gives me 34. And for FG, I need to plug in 4 times 6 plus 1, which gives me 25. So those are my final answers. So B is a very similar problem, so I want you guys to try it before I go over it. So B is the same idea, so you know that JK plus KL equals JL. So that means 4x plus 6 plus 7x plus 15 equals 120. Because it told you JL is 120, right? So the two small parts equals the big part. So I'm going to combine my like terms, so I get 11x plus 21 equals 120. So 11x equals 99. X equals 9. So again, I subtracted the 21 and then I divided by 11 to find the answer. So again, it's not asking me for what x equals. It's asking me for JK and KL. So again, I'm going to plug it back in. So JK is 4 times 9 plus 6, which gives me 42. And then KL is 7 times 9 plus 15, and that gives me 78. So that is what we do with segment addition postulate. So the next idea we're going to learn about is called congruent. So basically, if two objects are the same size and the same shape, then the objects are congruent. So again, if you have the note sheet, please write down the definition. So this is what it means. AB is 1 inch, CD is also 1 inch. So if you see the segment lengths are the same, right? They're both 1 inch. So the segment lengths are equal to each other. You can also say that they're congruent. The congruent sign is that. So again, you will be using this throughout the year. Make sure you know what congruent sign is. So we'll do some practice problems with these. So it's asking, are AC and BD congruent? So let's try it out. AC is -2 and -5. It looks like absolute value of -7. It is 7. BD, B is 3 minus 10, which is also absolute value of -7, which is 7. So yes, AC is congruent to BD. They're both 7. AB and DE, are they congruent? So we found out, oh, we haven't, sorry, never mind. AB is -2 minus 3, which gives you -5, absolute value of -5, which is 5. And then DE, AB, DE equals, D is 10 minus 14, which gives you -4, which is 4. So are 5 and 4 equal? No, right? So that means no, AB is not congruent to DE. The last idea in this lesson is called midpoint. So midpoint of a segment is a point that divides the segment into two congruent segments. Again, if you have the notes packet, please copy down this definition. So a midpoint, think about it, it's a middle point. Midpoint means middle point. So when something is middle, you know that both halves are equal, correct? The next thing you need to know is a point, line, array, or other segment that intersects a segment at its midpoint is called segment bisector. So segment bisector, a bisector is basically something that cuts something into two halves. So anything that goes through a segment and cuts it into half is called a segment bisector. So this line is what's cutting into two halves. So line L is the segment bisector of AC because it's cutting AC into two equal parts. Alright, so it's saying that Q is the midpoint of PR, which means this half is going to be equal to that half, correct? So if they're equal, then you set it up as equal. So that gives you x minus 7 equals 1, x equals 8 when you do the algebra. But it's not asking for x, it is asking for PQ, QR, and PR. So we know that they're the same. So let's plug it in into PQ, and you get 6 times 8 minus 7, so you get 41. It's always good, we know that they're equal, but it's always good to check if your algebra is correct. So I'm going to check that they're equal, so I'm going to plug it into here. So that's 40 plus 1, that is also 41. Good. They're both equal to each other, so they are good. So now we have to find PR. So PR, think about it this way. This is 41, and this is 41. So PR are two 41s, so PR would equal 82. All right. So I would like you guys to try the next question before I go over it. So over here, it's the same idea. U is the midpoint of TV, so we know that this half is equal to that half. So if they're equal to each other, we can set them equal to each other. So now, we're going to solve for the variable. I'm going to move my 8x here, so I get 4x. And I'm going to move my, you know what? I'm going to take it step by step. I'll slow down. I'll move my 11. Oh, sorry. I think I made a mistake. Whoops, sorry. That is not an 11. It's just a 1. So if you're moving my 1 over here, this becomes 12. I'm dividing by 4, so I get x equals 3. Again, I'm not looking for x equals 3. I'm looking for TU, UV, and TV. So always check if TU and UV are equal to each other. Then it guarantees you that your answer is correct. So TU is 8 times 3 plus 11. So that gives me 24 plus 11, which gives me 35. Then UV is 12 times 3, which is 36, minus 1. Well, 36 minus 1 is 35. So you are good. The last thing is TV. So you have your 35 and your 35. So that gives you your 70. Sorry about that. Okay, that is it for this lesson.